Technical debt, a metaphorical representation of the costs associated with implementing quick fixes or workarounds in software development, is a trade-off between short-term gains and long-term consequences. Developers may opt for expedient solutions that compromise the overall quality of the software, leading to increased maintenance costs, decreased system performance, and reduced code quality. However, technical debt can also be beneficial in certain contexts, such as meeting tight deadlines or responding to changing requirements. A qualitative analysis of 30 hours of developer discussions from 3 software development teams identified 3 primary themes related to technical debt: its benefits, including increased agility and flexibility; its issues, such as decreased maintainability and increased complexity; and the strategies employed by developers to manage technical debt, including refactoring and testing. The authors propose a framework for understanding technical debt, comprising 4 dimensions: the type of debt, including intentional and unintentional debt; the scope of debt, encompassing local and global debt; the time frame of debt, including short-term and long-term debt; and the impact of debt, including positive and negative consequences. This framework highlights the importance of acknowledging and managing technical debt in software development. The study's findings emphasize the need for developers to be aware of the trade-offs involved in taking on technical debt and to balance short-term needs with long-term consequences. The authors also discuss the limitations of their study, including the small sample size and potential bias in the data collection process. Future work is proposed to investigate the relationship between technical debt and software development methodologies, as well as the development of tools and techniques to support technical debt management. The study's results are presented in a taxonomy of technical debt, a framework for understanding technical debt, and a summary of the study's findings. These visual aids facilitate a deeper understanding of the complex concepts and relationships explored in the study. The author's framework provides a nuanced understanding of technical debt, highlighting both its benefits and drawbacks, and contributes to the existing body of research on the topic. This paper explores the collective opinions of software practitioners on technical debt, TD, through a large-scale survey of gray literature. The study aims to identify the most discussed aspects of TD and the sentiments connected to it. The research questions include identifying the topics commonly discussed by practitioners regarding TD, the issues they commonly complain about, and the benefits that paying TD can bring. The study uses natural language processing techniques, such as topic modeling and sentiment analysis, to extract the main topics discussed on TD and the positive and negative opinions regarding each topic. The data is collected from popular technology forums, including Stack Overflow, Medium, and DZone, using the keyword TD as the search query. The paper highlights the importance of understanding practitioners' perspectives on TD, as they face the daunting task of paying or accumulating TD. The study's findings can help in identifying the key aspects of TD that practitioners are most concerned about and the strategies they use to manage it. The paper also emphasizes the need for future research efforts to focus on AI-driven TD detection and management, as well as an analysis of the effect of TD on current software development methodologies such as DevOps. This research paper's methodology section outlines the data collection and analysis process from 3 prominent online developer communities: Stack Overflow, Medium, and DZone. The authors aim to investigate technical debt, TD, opinions and discussions among practitioners. Data collection strategies vary due to API availability and crawling policies. For Stack Overflow, the authors used the Stack Exchange API to retrieve questions and answers related to selected tracing tools, adhering to the API's daily query limitation. For Medium, where direct crawling is prohibited, the authors leveraged the platform's archive feature to obtain historical articles with specific tags, using tools like Beautiful Soup to traverse timestamp URLs and collect relevant articles. A hybrid crawling approach was adopted for DZone, combining manual search and Beautiful Soup. The data analysis process consists of 5 steps, as illustrated in Figure 2. The first step involves pre-processing the raw text data, including dividing texts into sentence-level instances, building bigram and trigram models, and performing text processing activities such as transforming text to lowercase, removing non-alphanumeric symbols, and lemmatization. The second step, informativeness filtering, employs a trained text classifier to filter out non-informative sentences, aiming to identify sentences containing useful information and screen out irrelevant ones. The authors provide examples of informative and non-informative sentences to illustrate this process. The subsequent steps in the data analysis process are not described in this section, but the authors mention that they will extract topics commonly discussed by practitioners and their collective opinions on each topic. This methodology is systematic and thorough, ensuring that the data collected is relevant and informative. The use of different crawling strategies for each platform demonstrates the author's adaptability and willingness to overcome technical challenges. The data analysis process is also well structured, with a clear focus on extracting meaningful insights from the collected data. The data analysis process in this study adopts a six-step approach, as depicted in Figure 2. It commences with preprocessing, where raw texts are retrieved and filtered for their informativeness. Subsequently, topic modeling is applied to identify the primary topics within these informative sentences. The selection of a suitable topic model is crucial for accurate results, with Gibbs sampling Dirichlet multinomial mixture, GSDMM, recommended for short text topic modeling. Domain-specific topic models can also be employed. Topic filtering is then performed to map each sentence to its corresponding topic, allowing for further investigation into subtopics or aspects within each general topic. Opinion mining techniques are subsequently applied to determine the collective sentiment regarding each topic in each aspect, providing a detailed reflection on the percentage of positiveness and negativeness for each topic. The interpretation of topics from lists of keywords is facilitated using ChatGPT-driven techniques, specifically the GPT-4 model, which has higher reasoning capacity and conciseness compared to its predecessor, GPT 3.5. A series of structured requests are entered to extract short topics related to each line of keywords, and the replies are structured to provide explanations for each topic. The AI-extracted topics are then compared to the original keyword lists for validation. The study emphasizes the importance of verifiability and replicability, with the complete raw data published in the replication package to allow for replication. The results of the study are presented in Section 3, which addresses the proposed research questions. Key equations and algorithms include the use of GSDMM for topic modeling and the application of ChatGPT-driven techniques for topic interpretation. The mathematical concepts underlying these approaches are rooted in probabilistic modeling and natural language processing. The figures and tables in this section provide a visual representation of the data analysis process and the results obtained. Figure 2 illustrates the six-step approach, while the tables provide a summary of the topics extracted and their corresponding explanations. Extracting topics from large datasets of textual data related to technical debt is a complex task. To address this, the authors employed a multi-step process. First, they pre-processed the data by retaining only natural language sentences and eliminating unnecessary content such as source code, URLs, and publishing dates. Sentence tokenization was then applied to obtain the list of sentences from each article. To identify informative sentences, the authors used a naive Bayes (NB) classifier and the expectation maximization for naive Bayes (EMNB) classifier. A manually labeled training dataset was created, consisting of 50% informative and 50% non-informative sentences. The performance of both classifiers was compared, revealing that the NB classifier outperformed the EMNB classifier, with an accuracy of up to 0.843. Topic modeling was then applied to extract topics from the large volume of textual data using the collapsed Gibbs sampling Dirichlet multinomial mixture (GSDMM) model. The model was trained with 36,523 informative sentences, using 30 iterations, alpha parameter 0.25, beta parameter 0.15, and an upper bound topic number parameter k of 30. This resulted in a GSDMM topic model with 20 topics, where 97.3% of sentences, 35,521, were associated with 8 topics. A topic filtering step was then applied to omit topics containing no more than 2.3% of the data. The results are reported in Table 1, which details the number of sentences and extracted topics. This process enables the identification of key topics related to technical debt, providing valuable insights for researchers and practitioners. The paper delves into the concept of technical debt, TD, as perceived through social media platforms, focusing on two primary topics. The first topic, the true cost of TD. Balancing short-term gain with long-term pain, underscores the unpredictable cost of TD and the trade-off between short-term gain and long-term pain. This includes subtopics such as the long-term consequences of shortcuts in software design, choosing quick solutions and incurring TD, balancing speed and sustainability in TD payment, financial analogies in TD, high cost of TD in financial terms, short-term gains versus long-term costs in TD, and the life cycle of TD in software development. The second topic, managing TD, a team-centric approach, emphasizes the importance of team effort in managing TD. Subtopics include solving TD through team collaboration, prioritizing TD, and the role of leadership in managing TD. The paper also discusses the need for a proactive approach to TD management, incorporating regular reduction of technical debt into the product lifecycle, and the importance of effective communication and problem-solving skills in managing TD. Technical debt management in agile teams, strategies and best practices. Effective management of technical debt, TD, is crucial for software development teams to maintain code quality, reduce costs, and improve delivery velocity. Practitioners emphasize the importance of collaboration, understanding, and proper tools and strategies in mitigating TD. To manage TD, teams should adopt suitable tools and strategies, such as isolating messy code and having a clear understanding of the type of technical debt incurred. Understanding TD as a concept is critical, requiring team effort and a clear understanding of the code's state and its impact on delivery. Different roles in the team, including general managers, technical staff, architects, and company leadership, have varying perceptions of TD, which must be acknowledged and addressed. Team involvement in decision-making is also crucial, as communication gaps can lead to poor decision-making and increased technical debt. Engineers play a vital role in managing TD, as they are often the direct inducers of TD through subpar code. Managing TD in agile teams is a continuous process, and adopting proper agile practices can help reduce and track technical debt. Paying down TD in agile sprints involves allocating resources, prioritizing tasks, and addressing TD and sprint backlogs. Allocating time and resources for TD management is essential, and sprint planning meetings provide an opportunity to decide how to use allocated time to solve TD. Prioritizing tasks, including TD-related ones, is critical, and understanding TD by stakeholders is a prerequisite for efficient prioritization. TD can be addressed continuously in sprint backlogs, alongside new features and bug fixes, and teams should ensure that TD is tracked and addressed regularly. Key findings and recommendations include adopting suitable tools and strategies for TD management, understanding TD as a concept and its impact on delivery, acknowledging and addressing different perceptions of TD across roles, involving teams in decision-making and communication, prioritizing TD-related tasks in sprint planning, and addressing TD continuously in sprint backlogs. By following these strategies and best practices, agile teams can effectively manage technical debt, reduce costs, and improve delivery velocity. Technical debt, TD, is a critical aspect of software development that practitioners emphasize should be considered in daily work and sprint backlogs. It can be understood as the difference between eventually repaid and sustainable code, with the latter requiring daily attention to avoid accumulating interest. Including TD in sprint backlogs allows teams to prioritize and address it regularly, ensuring it is paid down over time. Understanding the business impact of TD is crucial, as unchecked TD can affect development efficiency, software product quality, and customer satisfaction. Practitioners acknowledge that TD can hurt businesses in the long run, leading to costly rewrites, reputational risks, and regulatory issues. Individuals may struggle to repair their identity, and companies may face financial losses. Reducing TD can limit its potential cost on business development, but organizations often struggle to quantify the cost of TD. Tools like StepSize can help capture and track TD, enabling teams to prioritize the most important debt. Business managers may only see the value of features, not the technical debt buildup, which can lead to increased costs and longer development times. TD can also impact team morale and productivity, leading to low morale and decreased customer satisfaction. Implementing a process for managing TD can positively influence engineering team morale and customer satisfaction. Assessing the risk of TD on the business level is critical, as unchecked TD can pose significant risks to the organization. Practitioners propose building a debt limit and using quick feedback to reduce risk. Measuring TD requires adapted tools and metrics, which can quantify TD in a code base and help teams track, manage, and address code quality issues. Tools like Step Size, SonarCube, and Clockwork can facilitate TD tracking and management. Code editors like VBS Code and JetBrains offer extensions for TD tracking, providing features like issue linking, prioritization, and reporting. SonarCube is a popular tool for measuring TD, but practitioners share mixed experiences with its effectiveness. Overall, practitioners emphasize the importance of considering TD in daily work, sprint backlogs, and business development. Understanding the business impact of TD and using adapted tools and metrics can help teams manage and reduce TD, ultimately improving development efficiency, software product quality, and customer satisfaction. Technical debt, TD, is a critical issue in software development, significantly impacting maintenance cost and overall quality. The paper discusses various aspects of TD, including its measurement, management, and implications for product development. Understanding metrics to measure and track TD is crucial. Common metrics used include the number of bugs, code quality scores, and impact on maintenance cost. Tools like SonarCube are commonly used to analyze TD levels and violations. In product development, TD is often seen as a necessary evil. Practitioners must balance quality and speed, particularly in fast-paced markets where delivering new features quickly is crucial. This can lead to trade-offs between focusing on quality and incurring TD. Senior architects and project managers play a key role in managing TD and guiding the team towards sustainable development practices. Balancing new features and TD reduction is another critical aspect of software development. Allocating resources effectively is essential, as adding new features can create future debt. Agile projects face similar challenges, requiring careful management of feature development and TD reduction. Strategic prioritization of bug fixes and feature development is also necessary to ensure effective TD management. Overall, the paper emphasizes the importance of understanding and managing TD in software development, particularly in the context of product development and balancing new features with existing debt. Technical debt management is a critical aspect of software development, particularly in the context of feature development, code quality, and testing. It is acknowledged that technical debt, TD, is inevitable and can have a significant impact on the long-term sustainability and functionality of software. To address this, project teams must prioritize TD management alongside ongoing development tasks. Integrating TD management into feature development is crucial, as every new feature adds debt or creates a placeholder for future debt. Maintaining a balance between feature development and TD reduction is essential for code quality, and teams must focus on fixing bugs, conducting thorough testing, and implementing robust development practices. The role of testing in TD management is also emphasized. Testing is essential for managing TD, particularly in development environments with continuous integration and deployment. Automated testing can quickly identify and address bugs, ensuring that the development process does not add to the TD. Testing is also crucial for maintaining product quality and reducing manual testing efforts. Furthermore, testing is considered a tool for quality assurance in software development, facilitating the practice of reducing the long-term cost associated with TD. In microservice architectures, testing and refactoring are critical for managing TD, particularly when changes in code and architecture are frequent. The importance of testing and code review in improving code quality is also highlighted. Both activities can help development teams monitor code performance, identify security issues, and improve overall software quality. Using automated code review tools can help change the perception of code quality, especially for beginning developers. Finally, the impact of testing on TD in software architecture is discussed. Lack of testing can lead to an increase in TD or specifically architecture debt. Good testing practices, including design and documentation reviews, are essential for identifying architectural flaws and high-complexity areas in the code. The authors present a sentiment analysis of main topics and subtopics related to technical debt, TD, in software development. Figure 4 reveals that topics such as managing TD, T2, and understanding the business impact of TD, T4, have a higher percentage of negative opinions, while topics like the true cost of TD, T1, measuring TD, T5, and dealing with TD in agile development, T7, also exhibit more negative opinions than positive ones. In contrast, TD in product development, a necessary evil? T6, has a higher percentage of positive opinions. The authors further analyze the sentiment of subtopics within each main topic, categorizing them as benefits, issues, or neutral opinions based on the percentage of positive and negative sentences. Table 5 presents the results, with positive subtopics marked in green and negative ones in red. For instance, in the true cost of TD, T1, the subtopic The long-term consequences of shortcuts in software design, T1.1, has an overwhelmingly negative sentiment, while choosing quick solutions and incurring TD, T1.2, has a positive sentiment. Similarly, balancing speed and sustainability in TD payment, T1.3, has a negative sentiment, while financial analogies in TD, T1.4, has a positive sentiment. The authors also analyze the sentiment of subtopics in other main topics, including managing TD, T2, paying down TD in agile sprints, T3, understanding the business impact of TD, T4, measuring TD, T5, TD in product development, T6, balancing new features and TD in software development, T7, and code quality and TD, T8. The results show a mix of positive and negative sentiments across the subtopics, highlighting the complexity of the topic of technical debt. This analysis provides insights into the opinions and perspectives of practitioners on technical debt, revealing both the benefits and drawbacks of TD. The findings can inform the development of strategies for managing TD and improving code quality in software development. Figure 5 presents the sentiment distribution for subtopics across 8 distinct topics, denoted as T1 to T8. Each topic is further divided into subtopics, labeled as T1.1 to T1.7, T2.1 to T2.7, and so on. The sentiment distribution is visualized as a bar chart, with the z-axis representing the subtopics and the y-axis representing the percentage of positive, neutral, and negative sentiments. The sentiment distribution for each topic exhibits a unique pattern. Topic 1, T1, has a relatively even distribution of positive, neutral, and negative sentiments across its subtopics, with a slight inclination towards positive sentiments. In contrast, Topic 2, T2, displays a more pronounced positive sentiment bias, with a significant proportion of its subtopics exhibiting positive sentiments. Topics 3 to 8 exhibit varying degrees of sentiment distribution, with some topics displaying a more balanced distribution, while others exhibit a stronger bias towards positive or negative sentiments. The sentiment distribution for each subtopic is calculated using a sentiment analysis algorithm, which assigns a sentiment score to each text sample based on its linguistic features. The sentiment scores are then aggregated to obtain the overall sentiment distribution for each subtopic. This approach provides valuable insights into the sentiment dynamics of the topics and subtopics, which can be useful for various applications, such as opinion mining, sentiment analysis, and topic modeling. The findings highlight the importance of considering the sentiment distribution of subtopics when analyzing topics, as it can reveal nuanced patterns and trends that may not be apparent at the topic level. The results are likely to be used in conjunction with other analysis techniques, such as topic modeling and clustering, to gain a deeper understanding of the underlying themes and patterns in the data. Furthermore, the results can inform the development of more effective sentiment analysis algorithms and topic modeling techniques. The paper presents a comprehensive analysis of practitioners' collective opinions on technical debt, TD, in software development, gathered from various technical forums and social media platforms. The analysis reveals 8 main topics, TD in Agile Sprints, Managing TD. A team-centric approach, understanding the business impact of TD, measuring TD. Tools and metrics, TD in product development. A necessary evil. Balancing new features and TD in software development, code quality and TD, and the practitioner's overall opinions on TD. In the topic of TD in Agile Sprints, practitioners have positive opinions on allocating resources for TD, adopting a daily focus on TD, and prioritizing TD in sprint backlogs. However, addressing TD in sprint backlogs is viewed negatively. Regarding managing TD, team collaboration, proper tools, and strategies for reducing TD are positively received. The unclear definition of roles related to TD management is seen as an issue. The business impact of TD is discussed, with risk assessment and impact on team morale and productivity viewed negatively. However, the cost of TD on business development is seen positively. Measuring TD with code editors and tools, as well as using metrics to measure and track TD, are positively received. On the other hand, measuring TD with SonarCube is perceived negatively, along with analyzing TD levels and violations. In product development, practitioners are somewhat pessimistic about balancing quality and speed, and the general notion of TD from a development perspective is also negative. However, considering the trade-off of TD in fast-paced markets is viewed positively. Balancing new features and TD in software development is mostly received positively, except for handling TD in continuous software development, which is seen negatively. Finally, code quality and TD are discussed, with data metrics and testing in managing TD, and the impact of testing on TD in software architecture viewed negatively. Other subtopics on testing practices, such as testing as a tool for quality assurance, testing and refactoring in microservice architectures, and improving code quality through testing and review, are received positively. Automated testing in reducing TD has disputed opinions. Overall, the paper provides insights into the collective opinions of practitioners on TD, highlighting both positive and negative perspectives on various aspects of TD management and its impact on software development. Technical debt, a pervasive issue in software development, encompasses the true cost, team-centric management approaches, and the role of testing in code quality. Effective management of technical debt is crucial, as it can have significant benefits, such as quick delivery and fixes to the code base, encouraging collaboration among team members, and keeping development teams interested and motivated. However, it also poses challenges, including unclear roles, overemphasizing business risk, inadequate tools, and balancing quality with velocity. A qualitative study employing grounded theory methodology and sentiment analysis was conducted to understand practitioners' perceptions of technical debt. The study identified key themes, including the importance of active technical debt management, the need for better tools and metrics, and the role of testing in maintaining code quality. Developers often feel frustrated by recurring issues in managing technical debt, such as unclear roles and a lack of involvement in decision-making. Overemphasizing business risk can demotivate development teams and lead to ineffective technical debt management strategies. The study found that new features are often pushed without adequate regard for existing technical debt, slowing future development cycles and increasing maintenance efforts. In contrast, active management and paying down technical debt can bring significant benefits. The authors discussed threats to validity, including construct validity and internal validity, and the strategies adopted to mitigate these threats. The study's findings highlight the need for better tools, metrics, and management practices to ensure sustainable development and high code quality. Effective technical debt management requires a balanced approach, considering both business risk and technical debt. By understanding the challenges and opportunities associated with managing technical debt, development teams can adopt strategies to mitigate its negative effects and promote sustainable software development. The paper explores the application of inclusion and exclusion criteria in a multivocal literature review on open tracing tools, emphasizing potential threats to validity. It underscores the importance of mitigating these threats through independent evaluation by multiple authors and ensuring the reliability of conclusions drawn from the results. The study also surveys related work on technical debt, its impact, and management strategies, differentiating itself from previous studies through its scope, methodology, and size of surveyed opinions. The paper employs a novel methodological approach using large language models for data synthesis and provides a comprehensive view of possible new research opportunities and practitioners' suggestions for consolidating good practices while avoiding non-optimal ones. This page presents a comprehensive list of research papers, each focusing on various aspects of machine learning and artificial intelligence. The papers are categorized into different sections, including supervised learning, unsupervised learning, reinforcement learning, and deep learning. In the supervised learning section, several papers discuss the development of new algorithms that improve the accuracy and efficiency of classification models. For instance, one paper introduces a novel approach to feature selection using genetic algorithms, which significantly enhances the performance of support vector machines. Another paper proposes an adaptive learning rate strategy for stochastic gradient descent, leading to faster convergence and better generalization. The unsupervised learning section includes papers on clustering algorithms and dimensionality reduction techniques. A notable contribution is a paper that presents a new k-means algorithm with automatic cluster number determination, eliminating the need for manual tuning. Another paper explores the use of TSNE for visualizing high-dimensional data, demonstrating its effectiveness in preserving local structure while reducing dimensionality. Reinforcement learning is also well represented, with papers discussing various applications and improvements to Q-learning and policy gradient methods. One paper details an innovative approach to multi-agent reinforcement learning, where agents learn to cooperate and compete in complex environments. Another paper develops a new exploration strategy for deep reinforcement learning, significantly improving the efficiency of learning in sparse reward settings. Finally, the deep learning section covers advances in neural network architectures and training techniques. A key paper introduces a novel residual network architecture that achieves state-of-the-art results on image classification tasks. Another paper proposes a new regularization technique for preventing overfitting in deep networks, based on the concept of dropout during training. Overall, this collection of research papers provides a comprehensive overview of recent advances in machine learning and artificial intelligence, highlighting novel methodologies, algorithms, and applications across different domains.